Ladies and gentlemen, today we are going to solve the March 2026 Paper 2-2 for the IGCSE Additional Mathematics. Both Cambridge 0606 and 4037 Additional Mathematics have the same exam. I'll go through every question step by step, explain the working clearly, and also point out common mistakes students should avoid in the exam. So grab your calculators, your paper, and let's get started. Another thing which is worth noting is the instructions given on the first page about the rounding, the use of calculator, justifying your working. Remember, it's a 2 hours long paper. Total marks are 80 for this exam. And another interesting feature is that you are given a list of formulas. You can see a lot of formulas are given. So if you forget anything, you can always come back and check these. But when you are really good with it and you are in form and in practice, I mean, you hardly look at the formula booklet, right? But still, they are there for your support. Question 1. The function f is defined by f of x is 2x squared minus 6x plus 4. For all real numbers, this means the domain of the function is all real numbers. Part A. Write fx in the form this, where a, b, and c are constants. This is a completed square form. This is part of both normal math as well as additional mathematics. So how do you write it? You factor out the 2 in order to make the coefficient of x squared 1. Minus, this will be 3x. So I like to keep my 4 outside because I don't need that. All we need is just this expression inside the bracket. So 2, this will be x squared minus 3x. What's the half of the coefficient of x? That's a 1.5 or a 3 over 2. I like to write my answers as exact fractions. So let's keep it 3 over 2. Added square, subtracted square, plus 4. So now you can write it as x minus 3 over 2 squared minus 9 over 4 times the 2 is going to be 9 over 2 plus 4. Now this will be 2 times x minus 3 over 2 squared and minus a 1/2, right? And that's your answer to part A. You can always pause the video, try these questions yourself, and then you can come back and check my work. Part B, hence find the range of f. In order to find the range of a quadratic function, you need to know whether it's a parabola with a minimum turning point or a maximum turning point. In this case, it's one with the minimum turning point since the coefficient of x squared is 2. It's also wise to sketch your parabola just to have an idea. So the minimum point is 3 over 2 and a negative 1/2. Since my completed square form gives that, the x-coordinate of the turning point and the y-coordinate of the turning point. To find the range, you need the least possible value of the function. So function's value is its y value. So your function is always going to be above, more than equal to, a negative 1/2. So that is the range of this function. You can also give your answer as an interval notation, but any one is acceptable. So it's fine, whatever way you want to write it. Part C. The function g is defined by g of x is 2x squared minus 6x plus 4 is the same function. But this time it's different since its domain is restricted. It's below k, less than equal to k, where k is some constant. Given that g has an inverse, state the largest possible value of k. So we know that a function has an inverse, so it must be a one-to-one function. Look for one-to-one function. So students should be aware with the idea. There is another idea we use in functions that we put a horizontal line, and if it intersects more than one place, this function is not one-to-one. So you restrict your domain. Like in this case, if I cut this parabola in half, both halves are going to be one-to-one function since there is no turn, there's no repetition, right? So this time, since they are asking for the largest value, whether they ask for the largest possibility or the smallest possibility, in both cases, your answer should be the x-coordinate of the turning point. So I can say that x should be below 3 over 2. So the largest value k can have is 3 over 2. You can also write it as 1 over 2. Part D. The function H is defined by this is an exponential function, which is e to the power 3x minus 1, and its domain is less than equal to 0. Given that GHX exists, find GHX simplifying your answers. So the existence of a composite function. Look for the existence of a composite function. You should know that when a function is inside another function, just giving you some extra information because the question already says that it exists. But how does it exist? This range should be completely inside the domain of G. And if you ask about the domain of a composite function, so the inner function's domain is going to be the domain of the composite function. So this is a kind of a broad topic. Okay, so I need to compose my function gx, and another thing which is important, crucial, you need to simplify your answer. So I can either use my basic function or I can maybe use my completed square form as well, whatever way you want to do that. So let's take the normal function g of x, which is not in the completed square form, 2x squared, since in any case I need to expand my answer in the end. So this one is below 3 over 2. So the compatibility is there. So in order to get g h of x, I need to substitute h inside the domain of g, which is a e to the power 3x minus 1 squared minus 6 times e to the power 3x minus 1 and plus 4. So now you can't leave your answer like this since the question says simplifying. So simplifying means expand the brackets, right? Okay, so 2, this is going to be e to the power 6x minus 2e 3x and plus 1. Know your expansion, students. So you should be able to expand quickly. I mean, if you are not good with these identities, you can always expand these double brackets. Plus 6 and plus 4. So I'm getting 2e to the power 6x minus 4e to the power 3x plus 2 minus 6e to the power 3x plus 10. So finally, I can give my answer as 2e6x minus 10e to the power 3x and plus 12. So this is what they mean by simplifying your answers. Question 2. Points A and B have coordinates 1, 3 and negative 7, 1. So A is a 1, 3. B is a negative 7 and 1. The point P with coordinates 2a, so P has coordinates 2 and the y coordinate is not known, lies on the perpendicular bisector of AB. Part A, find the value of A. So the concept here, the key idea is the perpendicular bisector. So since it's the perpendicular bisector of AB, number one, we need midpoint of AB. So what's the midpoint formula? The sum of the x coordinates divide 2, the sum of the y coordinates divide 2. So 1 minus 7 divide 2, and 3 plus 1 divide 2. Negative 6 divide 2 is a negative 3. 4 divide 2 is a 2. That is the first thing, because the perpendicular bisector passes through the midpoint of 2 points, right? And next I need to get the gradient of AB. So change in the y's divide the change in the x, rise over run. This is a negative 2 divide negative 8, which is a 1 over 4. So for perpendicular lines gradient, you need to find the negative reciprocal of 1 over 4, which is a minus 4. Or you can say that the product of these two gradients is a minus 1. So this is coordinate geometry. Now I need to construct the equation of the perpendicular bisector. Passes through the point negative 3, 2 with a gradient minus 4. I can use any form I like. I like using point slope form. So y minus y1 equals to mx minus x1. So this is a negative 4x minus 12. Add 2 to both sides. So y is going to be a negative 4x minus 10. So now, since P lies on this line, the perpendicular bisector, in place of y, substitute a, in place of x, substitute 2. So negative 8 and negative 10 is a negative 18. Let's take a look at part B. The point Q is a reflection of P in the line AB. I mean, it's just a non-scale diagram. I'm not making it, okay, I mean, I can make it a bit accurate. So 1, 3, and a -7 and 1. So let's say if this is A and this is B, the perpendicular bisector will look like this. And it's if let's say P is here somewhere and Q is the reflection in the line AB, so AB is like a mirror line. It's like a mirror line to P and Q. So the image of 2 and -18 in this line is going to be this. Let's call this XY, and the midpoint is in the middle. So that's going to be -3 and 2. So that's like a concept map how to pursue this question. So you can always rewind. And if you find anything difficult, make sure you comment on the video and I'll answer you back, right? Okay, so now I need to apply the midpoint rule on P and Q, which is going to be 2 plus X divide 2. There are many other ways. Some do it just in their head. Some students just do the translation thing. So, but it's okay. Any way you want to do it. I'm just trying to give the idea that since it's mirror line, the object and image are equidistant from the mirror line. So 2 plus X divide 2 is going to be a -3. And -18 plus 2, sorry, plus y divide 2 is going to be a 2. So now x is going to be a -6 and -2. So -8 and your y coordinate is going to be 4 plus 18. So that is going to be 22. So q is a -8 and a 22. Question 3. We can see this graph given over here. And the diagram shows the graph of y equals to x plus 2, x minus 1, x minus 3. This is a cubic function, and it has 2 turning points, 3 x-intercepts. By drawing a suitable line on the diagram, solve the inequality. So when is your cubic function greater than 7? So what is that suitable line? So the left-hand side is a cubic function. The right-hand side is a line y equals to 7. So we need to check where is my function exceeding 7, right? So let's take a look at this. I am using the edge annotator and doesn't have a line feature. So I'll try to make the line as accurate as possible. Y equals to 7. Let's see. This is 7. So this is the line. Sorry about that. It's not accurate, but in your exam, you will be making it very straight using a scale. So this is a line y equals to 7. So let's see, where does it intersect, right? This thing. So I have here like a -1.3. And this point is -0.2, right? And this point is a sorry, a +3.5, this point. Okay, so the region technically is this region. This is the part where your function is more than 7, and also this region over here. So how do you give your answers? So your answers should be, number 1, you can write x should be greater than a 3.5. And the other part is, the other inequality is x should be within a -0.2 and a -1.3. Question 4, part A. A 6-digit number is to be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 9 digits since 0 is not part of it. No digit may be used more than once in any 6-digit number. Find how many 6-digit numbers can be formed in the following cases. Part A1. There are no further restrictions. So it's a 6-digit number, 1, 2, 3, 4, 5, 6. One way of doing this is like you can put these 9 digits, 9, 8, 7, 6, 5, and 4, and multiply this to get the answer. This is a counting principle way of solving this. Or you can use your calculator straight away. So 9p and 6. So let's use that. 9p6. And I'm getting 60480. 60480. Part 2. The 6-digit number includes the digit 4. So in these 6, 1, 2, 3, 4, 5, 6, there is a digit 4 somewhere. So we are not sure which place this digit 4 has taken. So there are 6 possibilities for the digit 4 to be included in this 6-digit number. So whenever the question has restrictions, first you need to settle the restrictions and then you apply the counting principle. So what's the idea, like the restriction, like it's settled for 4, but what about the other remaining 5 digits? So they will be any of these 8. So 8p 5 times it. Now I settled the restriction, applied the counting principle. Let's get this answer. So 6 times 8p5. So I'm getting 40320. 40320. Okay, let's move on to the next part. Part B. A class contains 10 girls and 12 boys. A group of 6 students is to be selected from the class. So this is a combination problem now. There must be at least 2 girls and at least 2 boys in the group. Find the number of different selections that can be made. So you need to model it. I mean, you can either do it in your head or you can model it using the way I am doing it right now. So there are girls and there are boys. Altogether, there are 10 girls and there are 12 boys. So the restriction here is at least 2 and at least 2. So it means more than equal to 2. So let's see. One possible combination can be that you can choose 2 girls and 4 boys. So altogether, there are 6 students. Or you can choose 3 girls and 3 boys. Or if you choose 4 girls, you will have to choose 2 boys and no other combinations. So how do you do this? 10C2 times 12C4, or, which is a plus, 10C3 times 12C3, or 10C4 times 12C2. Let's use the calculator to get these. 10. Okay, I'm going to try to solve it quickly. 12C4 plus, that will be 10C3 times a 12C3, or a 10C4 times a 12C2. And I'm getting 62535. 62535. Question 5. The diagram shows a design for a badge. ABC is an equilateral triangle with side x. The arcs BCC and AB are parts of the circle with center A, B, and C respectively. So it's an equilateral triangle in the middle and these arcs around. Part A, write down the size of angle ABC. So this is ABC and it's an equilateral triangle. And this is in radians. So we need to give our answer in terms of pi. So this is a pi over 3. Since the angle is 60 degree, but we cannot give the answer 60 degrees. In radian, it has to be pi over 3. Okay. Part B. The area of the badge is 2 times pi minus a root 3 centimeters square. Find x. So there are 3 segments and an equilateral triangle. So I need to add all of these. How do we get the area of the segment? So area of segment is going to be area of the sector minus the triangle. So this is x, and this is a pi over 3. So I'm using half r squared, which is x squared, and a pi over 3. This is the sector area. You can check out the formulas in radian for area of sector and the arc length thing. Okay, and subtract the area of the triangle, which is half A, B, and sine of C. So the angle in the middle is a pi over 3. Okay. The the answers are supposed to be in exact because we have the exact. So this is a requirement. You should be able to identify the exact values of sine 60, 45, and 30. And since this is a calculator paper, so you can also use your calculator to get these answers. So x squared, and I can write a pi over a 6 minus this will be x squared. And so this is a root 3 over 2. So I will get root 3 over a 4. So I can write my final answer as x squared and a pi over 6 minus a root 3 over a 4. So this is one segment. So I will add 3 of these. Okay. So I need to keep an eye on the diagram as well. So I'm completing my solution over here. But in your actual exam, you will be giving answers over here. Okay. So let's see. I can do the triangle area, which is the area of the triangle is going to be half x, x, and a sine of a pi over 3, which is the same thing as I did earlier. This is going to be x squared and a root 3 over a 4, right? Since this is a root 3 over 2, you can check this. All right, so now I will multiply my segment with 3. So 3x squared pi over 6 minus a root 3 over 4 multiplied with 3. Add a triangle, which is x squared times a root 3 over a 4, and put it equal to this answer, 2 pi minus a root 3. So let's see. X squared, if you can factor out the x squared, this will be pi over a 2 minus a 3 root 3 over a 4 plus a root 3 over a 4 and equals to 2 times a pi minus a root 3. So I can further simplify this like pi over a 2 minus 2 root 3 over a 2. So that will be root 3 over 2 equals to 2 times a pi minus a root 3. Okay. So nowhere does it say that you need exact answers. So you can just straight away use your calculator to give. If the question says exact answers, then you need to be careful about that. So, okay, this is the case. I mean, I can put this in my calculator. 2 times a pi minus a root 3. Divide the whole thing by pi minus, let's put a fraction over here. And pi minus a root 3. And divided by a 2. Okay. And get your answer. That's a 4. Well, that's good. This is 4. So x is going to be not a plus minus 2 this time, since it's a length, so it has to be positive. And that's my answer. Question 6, part A. The diagram shows part of the graph of y equals to 1 plus tan half x, where x is measured in degrees. So this is a tan graph. Part 1. Write down the period of 1 plus tan half x. So you need to learn the trick to find the period. So whenever this kind of situation is there, I'll solve my answer here. Put half x equals to 180 degrees. So you might be thinking why, since 180 is the actual period of the tan graph. If this kind of a question pops up on a sine or a cosine, so you'll put it equal to 360. So just take notes on this one. So x will be 360 degrees. That is my period. Next part. They're saying part 2. Write down the equation of the asymptote A. So asymptote is always in the middle of its period. So this means that this thing over here is going to be 180. So this thing will be, since after 280s, this is showing up, right? So since its period is 360, so you can add a 360 on this one. So let's go and do 360 plus 180. So this is a 540. So since they're asking for the equation of the asymptote, so you will write it x equals to 540. Remember, equation of a vertical line is x equals to something. Let's get into the part B of this question. On the axis below, sketch the graph of y equals to 3 cosine 2x plus 1 for negative 180 to 180. So there are some transformations going on. The amplitude, first of all, is 3. So my wave is going to go 3 up and 3 below from the midline or the principal axis. So the midline is y equals to 1. Remember, you need to be familiar with the graphs of this kind, bx plus c, and it can be for sine and cos and tan, all of them. So this is the amplitude. I'm just giving you some idea. Amplitude. This one is, the period change factor. Sometimes we call it the frequency factor as well. Frequency factor. And this C is known as the principal axis, or you can sometimes call it the midline as well, right? So the equation of the midline is this. Okay, let me just, I can make an imaginary one. So y equals to 1. This is where my graph is going to start. So that is now the x-axis for your graph. You can think it this way. So from your line 1, if you add 3, you go to 1, 2, 3, which is 2, 3, 4, 4. So it goes max 4 and min 1, 2, and 3. So this is a negative 2. So sometime, I mean, you can even coordinate your graph like this as well. So it helps you to understand that your graph cannot exceed or fall below -2, cannot exceed 4 or cannot fall below -2. So that's the range kind of a thing. You can say this is the range of the strict function. Okay, so now another thing is its period is different now. So put 2x equal to 180, sorry, 360 in case of cos. So x will be 180 degree. I usually tell my students this is the new period, the changed period, right? So I can see it's a cos graph. It starts here somewhere and its period is 180. Now you don't need to be very specific since it's just a sketch. So, but you can put these dots like here. This will help you to sketch your cost properly. And I'll tell you what do I mean by that. So if you wish to find this is a 45 and this is 135, but don't mark it. That's okay. You can just sketch it now. Okay, so let's see how it goes. I'm using my emulator to sketch it. So it goes like this and all the way to the minimum and here like this. Oh, wow. It seems nice. So on the other side, it looks like this. This is the lowest point, and from here, it will go all the way till this place, right? And that is my answer for part B. Question 7. A ship is sailing with a speed of v kilometer per hour. The sailing cost per hour, C dollars, is given by this function. Part A. Find the speed that makes C a minimum. Justify that this value of C is a minimum. This is a calculus question, stationary values. So you need to differentiate it, put it equal to 0 to get the stationary value. And then to justify, you need the second derivative. So first, rewrite your expression, v squared plus 3000 and v to the power -1 plus a 100. Let's differentiate dc over dv. This is going to be 2v minus 3000 and v to the power -2. Put it equal to 0. Now try to solve it to get the V value. 3000 divide V squared. V cube is going to be a 1500, and V will be a cube root of 1500, which we can find cube root of 1500, which is 11.4471, approximately 11.4 kilometer R inverse, right? So this is the speed that makes C the minimum. So how do you justify it's a minimum? Let's re-differentiate d squared C over dv squared. This will be 2 plus a 6000 and v to the power negative 3. So now you need to substitute the value of v in order to check its nature. So sub v equals to a cube root of 1500. If you substitute, you will get 2 plus 6000 and divide just a 1500. And that's going to be 4 plus 2, 6, which is greater than 0. And hence, the nature is minimum. If your double derivative's value is more than 0, it's a minimum value. If it's less than 0, it's a maximum value. And if it's 0, that's not part of the course for additional mathematics inflection points. Right. Okay. So now they're saying, hence find the minimum sailing cost for a journey of 150 kilometers. So what does this expression give us? It gives us cost per hour. So first you need to calculate the cost, the minimum cost. Let's get this. So I'm going to do it here. C min is going to be, this is going to be, I'm using the exact value. Square this plus a 3000 divide 1500's cube root and plus a 100, right? So I'm getting like the cost per hour, and then we can evaluate that. So let's do shift cube root 1500 and a square of that plus a 3000 over cube root of 1500 and plus, wait, plus a 100. This is a 493.1112, 493.1112. You should be solving this over here in your exam. Okay, so this is per hour cost, the minimum cost. So when the distance is 1500 kilometer, 150 kilometers, and the speed is, the minimum speed is a 1500's cube root. Let's get the time, and this will give us a time in hours, cube root of 1500. Let's get this value. So it's 150 over a cube root of 1500. So it's a 13.1037 hours, right? So this is per hour cost, and this is 13.1037 hours. So what are we going to do? We need the min cost. Let's multiply this with 493.1112. And this will give me 6461.58, 6461.58, approximately 6460, right? And that is the cost in dollars. Question 8. A circle has center -2, 0, and a radius 5. A line has the equation y equals to 2x plus k, where k is a constant. The line does not meet the circle. Find the set of possible values of k. So first you need to write the equation of the circle, x plus 2 whole squared plus y minus 0. So you can just write y squared equals to r squared, so 25. So learn how to write equation of circle given the radius in the center. And then the line's equation is 2x plus k. So this line does not meet the circle. Remember, circle is also a quadratic expression. So you can use the idea of discriminant to help you solve this kind of question. Line does not meet the curve. So what's the key idea? B squared minus 4ac should be less than 0. Okay, so let's substitute the y value. This will be x plus 2 squared plus 2x plus k squared and equals to 25. X squared, 4x, 4. Let's make it a bit quick. A lot of calculations, but remember, it's 8-mark problem. Plus k squared, subtract 25, put it equal to 0. Now I've got a 5x squared. I'm trying to standardize my equation. How many x values do you see? This one and this one. So you can write it as 1 plus k x. And now the terms independent of x are k squared, a plus 4 and a minus 21, so negative 21 equals to 0. So I've got my A value, I've got my B value, I've got my C value. Let's apply discriminant B squared minus 4AC. And what do? You put it less than 0 since line does not meet the circle. Okay, so this will be 16 and 1 plus 2k plus k squared and minus a 20. K squared minus 21. This is not necessary, but maybe you can divide the whole inequality by 4. This will make your calculation simpler. I mean, you can work without this as well since it's just a calculator paper. So 4, this will be 1 plus 2k plus k squared, and this is going to be a negative 5, k squared minus 21, and less than 0. 4 plus 8k plus 4k squared minus 5k squared plus 105 less than 0. I'm getting a negative k squared plus 8k and 109. I like to make my leading value positive. You can time with a negative, this thing. Okay, so I mean, if it's factorizable, you can go with that. But since it's a calculator paper, I can just show the examiner that I'm using quadratic formula. All I need to solve the quadratic inequality is the roots, the x-intercept. First, I need to read something. Okay, they're saying set of possible values. So you know what I was looking for. Maybe if they're saying exact values of k, then I need to keep my answer as third forms. So it doesn't say so. Let's see. You can give it any way you want to. Divide a 2a. Okay, once you're done this, what you can do, you can just go to setup and equation, go to quadratic, and just put in. See, you haven't lost your method marks. You've shown the examiner that you are using the correct method. And now I can get 4 plus 5 root 5. And what's the other one? It's going to be 4 minus a 5 root 5, right? So make a parabola like this. Put your quadratic expression on that. So this is a 4 plus or root 5. 5 root 5. This one. And this one is a 4 minus a 5 root 5, right? So when your inequality is greater than 0, you are looking for the region above the x-axis. So this is the region above the x-axis. So your solution is going to be this side and this side. So how do you write the final answer? You can write it like k should be above 4 plus a 5 root 5, or k should be below a 4 minus a 5 root 5. Since they haven't mentioned exact, you can either give your answers 3 significant figures as well. Question 9, part A. Show that this expression can be written as this expression. The skill is trigonometric identities. So write tan in terms of sine and cos. The reason being that the result you're trying to get is in terms of sine and cos. Cot is a reciprocal of tan, but instead you can write it as cos theta divide sine theta. And secant is a reciprocal of cos. Now you need to express it as a single denominator, and that is basic algebra, part of normal math as well. So you need a sine time to the numerator and the denominator. This will become sine squared theta. And here in the second fraction, you need to time and divide with the cos theta. So this will become cos squared theta. And here again, sine, so 2 sine theta. And by doing this, you know that this thing is a 1. So hence, 1 plus 2 sine theta over sine theta and cos theta. So this is shown. Part B. Hence solve the equation this. So when the question says hence, look at the result that you used in the earlier part. So this one and this one is exactly identical. The only difference is the 2x is switched with theta. So this is a manipulated angle equation. How do you solve it? First, rewrite it in terms of the result that you showed. 2 sine 2x and divide the whole thing with the sine 2x and cos 2x. Put it equal to 0. Okay. And always change your domain accordingly. The reason being that you are not solving this for x. Instead, you're solving it for 2x. So this will become negative 360, a 2x, and a 360. When a fraction is 0, remember, numerator is 0. So 1 plus 2 sine 2x. If your denominator is 0, then your fraction's value is math error, undefined. Sine 2x is going to be a negative 1/2. This is, by the way, an exact value, which is, first you ignore, how do you solve a trig equation? You ignore the negative sign, and you get a basic angle of 30, but you put your cast diagram and put 30 in this quadrant and this quadrant. Reason that sine is negative in these quadrants. So let's get these values. I can move clockwise and anti-clockwise as well. So for clockwise angles, I'm getting a negative 30 and a negative 150. So you can use calculator for this, since this is a non-calculator, sorry, a calculator paper, but I'm just solving it kind of non-calculator way. So this is going to be 180 plus a 30, which is a 210. And this one is going to be a 330, right? So clockwise angles are positive and anti-clockwise angles are, the anti-clockwise angles are positive, the clock ones are negative. So all these are answers for 2x, negative 150. It doesn't matter, you can write it in any order, but I'm just writing it like this, 330. Now you can divide each of them by 2 to get the answers, final answers for x. So minus, this will be a 75. So minus 15. This will be, I mean, you can use calculator to divide 2. So that's going to be 105. And finally, 330 divided 2 will be 165. So these are degree answers for this part, right? Okay, so let's, there's another part. Let's take a look at that one. Part C, solve the equation this, where x is in radians. So before you begin, I mean, it's good to convert your angles in radian in your calculator, right? Okay, so we know there's a result that 1 plus tan squared theta is a secant squared theta. It's given on the first formula booklet page as well. So in order to make it in a single variable, I can write this. Tan squared can be written as secant squared x minus 1 and a minus 1. So let's get rid of these minus 1s. And another thing which is important, again, change your domain. Subtract 1. So negative 2 and x minus 1 and a 2. So when you change your domain accordingly, you don't miss out on any of the crucial angles. So this is going to be secant squared x minus 1. I can either suppose something for secant as well, solve it that variable, but this is okay. I can just factor out the secant x minus 1, and this is going to be secant x minus 1 and a minus 3. So when secant x minus 1 is a 0, this is not applicable since cos is going to be undefined, right? Since it's a reciprocal 1 divides 0. So cos is going to be undefined when secant is 0. Okay, and by the way, that's later in the course in A levels. You'll learn to sketch the graphs of secant, cosecant, and cotangent as well. And there you will check out that they are not defined within 1 and -1. Okay, so secant x minus 1 is going to be 3. This will give me cosine x minus 1 equals to a 1/3. So now I need to find cos inverse 1/3. Let's see, what do we get? Okay, so cos inverse a 1/3. And this will give me 1.23096. 1.23096. And you can make your cast diagram again, CAST. This quadrant and this quadrant, right? 1.23096 and 1.23096. And since I cannot exceed 2 and cannot descend -2, so these are going to be the only possible answers, right? So you will get a 1.23096 and a negative 1.23096. Since what happens if I do a 2 pi minus this, I will definitely exceed 2, x minus 1. So you need to keep an eye on your domain as well. So this will be 2.23. Yeah, 3 sig answer. This can be the 3 significant answer. Okay, and when you add 1, this is going to be a negative 0.23. And don't forget the 1 as well, right? For the accuracy. Question 10. In this question, time t is in seconds and displacement s is in meters. For time greater than equal to 0, a particle moves on the positive x-axis. At time t, the acceleration of the particle is this. So there's some information. It's a kinematics question, and we treat motion as in one direction, like in the x-axis. Though it's a non-linear motion, but we treat it as the x-axis. It makes things simpler. Okay, so acceleration's expression is given, and this is a function of time. At t equals to 7, the velocity of the particle is 4. So let's keep this boundary condition. These boundary conditions or initial conditions are later used to evaluate constants. Part A. Find the time when the velocity of the particle is 0. So in order to find the expression for the velocity, you need to integrate the acceleration. So let's do v and integrate 2t minus 9 and dt. This will be 2t squared divide 2. So I'm just writing t squared minus a 9t and plus c. Now we put v equals to 4, this 7, and minus 9 into 7, and plus c. So let's evaluate this minus 49 plus 63. So I can use my calculator to quickly get this minus 49 plus 63. This is c will be 18. So the expression for the velocity will be t squared minus 9t and plus 18. Now the question demands that find the times when the velocity of the particle is 0. So you need to put it equals 0. So this will be t minus 6 and a t minus 3. Factorization, you can also use quadratic formula. So time will be 3 seconds or time will be 6 seconds. Okay. Part B. At time t equals to 12, the displacement of the particle from the origin O is 150. So part 1. Find an expression for the displacement of the particle at time t. So in order to get the displacement, we need to integrate velocity now. So let's integrate. This is going to be t squared minus 9t plus 18 dt. T cubed divide 3 minus 9t squared divide 2 plus 18t. And don't forget the constant c. And this is s. So now we have another condition which is given at time 12. S is 150. So we can use this to evaluate the constant. So 12 cubed divide 3 minus 9 over 2, a 12 squared plus 18, a 12, and plus a c. A lot of calculations. Let's try this 150 minus a 12 cube over 3 plus a 9 into 12 squared over 2. Oh, sorry, I messed up. I need to, I just, it happens sometime while using this emulator and I think the normal calculator as well. So I need to add it now, 9 times the 12 squared. Thank goodness. Okay. Over a 2 and minus 18. Again, I'm doing the same thing. Minus 18 times a 12, right? So make sure you are careful about these things as well. Let's go. And I'm getting 6. It looks like a nice value, C6. So now the displacement's expression is going to be, since they're asking for the expression for the displacement, t cubed over 3 minus 9, t squared over 2, plus 18t, and plus 6. There we go. All right, so let's see. Is there anything else? They're saying find the distance traveled by the particle in the first 6 seconds. And this is a good one. So for this, I would highly encourage it that you use the sign diagram or the displacement diagram. So we know that distance can be treated like this. This is O. So at t0, we know that s is going to be 6. You can check that from this expression. And the particle is heading this way, right? Now, why t equals to 3 is a crucial value. Since I'm trying to get the distance from 0 to 6, but there is an instantaneous rest at 3. So this is a critical value. Critical value. You need to test it. And for those who are using calculus, they will use the limit once 0 to 3 and then later 3 to 6. Reason being that you need to differentiate. But I already have the displacement expression, so I can use that. So I definitely know that my particle is going to change direction, and I'll show you that. Why? Okay. So let's plug in. 0 gives me 3, so 0 gives me 6, and at 3. So let's plug in 3 cube over 3 minus 9. Oh, why am I doing this? Okay. 9, 3 squared, and over 2. The good thing is I check that times 3. And there is a plus 6 as well, right? Plus a 6. I think I messed up again. Yeah, I did. Oh, well. Uh, I don't know. Something is going on with my calculations right now. So, okay, I'll be careful now. Minus 9, a 3 squared. The good thing is this calculator shows the display on top. Like, I remember back in the day when I was a young student of mathematics, calculators were not this advanced, though it's not very long time ago, but things are really drastically improving. So I can see my what I've written, right? So I'm getting a 28.5. So this gives me a 28.5. Now, what's the next crucial value? I can already make a diagram. I know my particle is going to change. So what's the key idea behind it? Displacement's turning value is when velocity becomes 0. Since velocity is the first derivative of displacement, you can rewind and listen to that again. Okay, now what's the next crucial value? I've got my step in, so I can just switch the 3's with the 6. And let's see, what do I get? Okay, so I'm getting a 24. So definitely it has turned back at t is equal to 6, right here somewhere. So let's get this bit of distance and this bit of distance. Distance 1 plus distance 2 is going to be your answer. So first part is going to be 28.5 minus a 6. So this is a 22.5, 22.5 forward. And then 28.5 minus a 24. So that's the backward distance, which is a 4.5. So just add 22.5 and 4.5. This is 27 meter. And that is my answer. Question 11, part A. Find in descending powers of x the first 3 terms in the expansion. This. Give each term in its simplest form. This is a binomial theorem question. So first, you need to raise to the power 9, then 9, 1, or let's write 9c1 x squared The difference of these top and the lower value is 8. That is the first term's power. And 1 over 2x power is this lower value sub in the combination. So 1 plus 9c2 x squared raised to power 7 and 1 over 2x raised to power 2 dot dot dot. This will be x18. This is a 9x16 divided 2x plus 9c2. Let's quickly check. 9c2, that's going to be 36 x to the power 14 over a 4x squared. And now I can further simplify x18 plus 9 over 2 x15 and plus 9x to the power of 12. I'm using indices as well. And that is the answer to part A. Part B, the expansion of this x squared plus 1 over 2x to the power of n, where n is a positive integer, has a term that is independent of x. Show that n is divisible by 3. Okay, so you need to learn the general term rule for these kind of questions. So any term in a binomial looks like this: NCR, x squared raised to power n minus r, and 1 over 2x raised to power r. And remember, very important, n and r are positive integers, right? They belong to positive integers. So now extract only the x values. Forget about everything else, just the x value. And this will be xr. Use the index law. This becomes n minus 3r. And for the term independent of x, you need to set it equal to 0. Reason being that in the term which is independent of x, there is no x. So 2n minus 3r should be 0. And this gives me 2n equals to 3r. So clearly you can say that since n is an integer, so 2n is even, right? I'm just trying to justify this proof. This implies that 3r is even also. So now we have 3r, which is even. I need to show that n is divisible by 3. Even and a multiple of 3, right? There's a multiple of 3 as well. Now, there are a lot of different ways in which I can justify that n is divisible by 3. So let's say n can be written as 3r divided 2. So we know that's an even number and divisible by 3. So half divide 2 will also be an even number divisible by 3. By the way, I only had to show that it's divisible by 3. Hence, n is divisible by 3. You can even give slightly shorter explanation, but I was just trying to convince the examiner what do I mean by my justification. And that's it for this exam. And if you have come this far, I am really, really happy. And I believe that you are strongly preparing for your IGCSE Additional Mathematics. And another important thing that I want to share in the end of this video is, like, if you like my content and if you feel like this is really worth watching, please do subscribe to my channel because it means a lot for the growth of the channel. Keep watching for more useful resources. This is Global Math Mentor, over and out.